778, swim in rising water. On an end-by-end grid, each square represents the elevation at this point. Didn't I do something similar to this? Maybe not. Okay. Let me double check real quick. Sorry. I mean, I guess not because they told me I didn't do it. But, okay. Those are the language I would use anyway. Okay, 778, swim in rising water. On an end-by-end grid, each square represents the elevation at that point, I and j, a grid sub ij. Now rain starts to fall. At time t, the depth of water everywhere is t. You can swim from a square to another four directionally adjacent square, if and only if the elevation of both squares individually are at most t. Sorry, I'm using my funny voice. You can swim infinite distance in 0 time. Of course, you must stay within the boundaries of the grid during your swim. You start at the top left corner. What is the least time until you reach the bottom right square? So that already feels like a binary search problem, but let's see. So it's 50 by 50. What are the numbers? Grid. Oh, it's just from. So the numbers are from 0 to 2500. So basically, it's just connectivity with. I mean, I think my intuitive sense is binary search. And if you binary search over 2500 numbers, well, that's like 20 or less than 20, because 20 is 2 to the 20 is a million. Yeah, and then you do a depth first search on that, and that's linear time, which is of n square. N is 50 in this case. So my algorithm would be log of n squared times n squared, which is n squared log n. Is that it? So that's 2500 times log of 2500-ish, which is less than a million. So that should be okay. Yeah, I think that's it. Let me know in the comments if I need to slow that down, because I feel like maybe I'm confident on this one a little bit, but yeah, maybe times a little bit, but still should be under a million operations, which should be fast enough. Okay, well, we will see if what I'm saying is true, but okay. My wing keeps, my watch keeps pinging me. Is it a square? Oh, it is a square grid. Okay. Times n plus 2, say. Okay. If we could connect, that means we could get it for cheaper. So let's do right in a minute. And then for just by default, let's just return n times n. Maybe n times n plus or minus 1 is. Okay. So at 0 time, and then at 1 time. At 3, so okay, so at time 3 you could, so it's inclusive. Okay, so that should always be true. In this case it's 16. Okay, fine. And then now def good x. Okay, so what makes it good? Okay, so that means you can get from top left to top or to bottom right. How do we want to do it? Let's just do buffer search. You can do that for I think 2500 for that first search may be cutting it close, so maybe not, I don't know. Just typing out the directions. Well, this will always be false because, okay. If this is between x and grid of this is equal to or less, or if this is smaller than now, then we can add it to the queue, and also could use a billion when maybe we use it. Yeah, maybe we'll see. It shouldn't matter. Maybe that's not true actually, but okay. And then put it on a queue. Okay. And now at the end, return false. Let's say if x is equal to n minus 1 and y true. And actually we could probably even do this a little bit earlier. Okay. Whoops. Also, I always forget because the way I write this. Is it not insert? Is it add? Too many APIs in my head. Oh, whoops. Probably ate my tuples. Okay, let's try this one then. Oh, what? 16.5? 16.5 would do it, but I just need to do that. Whoops. Okay. Yeah, good catch though. Is there any edge case I need to think about? Maybe just one element. I guess it's only one. Oh, oh, I guess it has to be at least 2 elements. Well, I guess that's the input's probably good then. Cool. All right, let's take a look. Oh, I should try the big case, but oh no. Oh, because I don't. Okay, that's a good edge case actually, because I don't look at the limit of the first one, so we have to start at something smaller. Okay, you got me. I was so confident too, but that's fine. If now is bigger or smaller? Smaller than grid. Return false. Okay. Actually, I was thinking about like how to handle it, but then it was a fleeting dot that did not come back, unfortunately. So let me see. There's another one. Another silly mistake. Okay, cool. All right. Well, terrible on memory usage because I keep on decoding new stuff, but that's fine. Oh no. Oh wait, no, I misread that. Well, terrible something, but people are doing much faster. I think you could find maybe there's a smarter way actually. Actually, I think now that I think about it a little bit, you probably could have done. Yeah, you probably could have done it in one breath first search and then like, or maybe not breath first search, but like it's the shortest path problem where yeah, you get to each point and then the cheapest route that you could get to that point or something like that. Yeah, but I didn't do it that way. So, and running time was fast enough, I guess. Actually, now that I think about it, I don't know why I did it my crazy way, even though I thought that, I mean, it's running time should be okay, but it's just, coding is not ideal for an interview, but you can actually do something like some sort of connected components on, uh, like I think one thing that it reminds me of actually is kind of um, like a minimum spanning tree actually. And you could do that in linear time very quickly. Um, and then you use a greedy Costco E algorithm where, yeah, for every time you just take the smallest element that's in this. Yeah, I mean, but essentially, yeah, Costco you could do it in Union Fine or other thing like that. So yeah, so actually, whoops, I guess I was too lazy to think about this problem because I just was like, okay, this solves it, and I didn't really think about it that much. But clearly, look at the submission time. I think you can actually solve this as some sort of. I mean, I think it's not a minimum spanning tree, sorry, but you are trying to find a spanning tree for which um, there's a cost, and it's like a variation on the shortest path spanning tree. Maybe it's minimum, I don't know, but 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 the core part of those spanning tree algorithms is that it is greedy, and I think if you just construct um, things such that like you connect stuff every along the way, and you have a lookup table to see where it connects, then like you have like iron connecting, and you keep merging, similar to like the Costco algorithm. Or one of the minimum spanning tree algorithms, and then you could do that in linear time because you only have v plus e, which is just v plus v times 4, so which is all v obviously, where v is the number of vertices, which is n squared, so that should be fast. Wow. But I did not do that, so uh, cool. What is there to say about this problem? I think actually, for a hard problem, this is okay. Difficulty, I think, how long did I end up taking? Do I ramble? Okay, 15 minutes. I mean, I didn't get the right solution, but right enough, which is actually makes it a fun problem. I think now that I think about it, maybe makes it a good interview problem in the sense that, well, one, it's just greedy. Two, greedy-ish. There's a spanning tree thing, and really there are a couple of ways to do it clearly because I did it another way and it seems to fit. So at least you get to explore with the interviewer like different ways to kind of approach this and kind of like look at the constraints and kind of attack it that way, um, which I think is fine. It's still a little bit on the tricky side. I don't like greedy prompts in general, but that's a very personal bias only because I feel like I just am terrible at greedy algorithms and that I have to prove them correct. I mean, I know that people always mention about the Metroids and then try to like, I can't do it. It's just maybe something I need to practice in with a lot. And I couldn't, my head did not even go that way for this one. So, but yeah, but that said, you could probably do some. Yeah, I mean, I think actually you could have done it with one depth first search if you have a 50 to the fourth array. But that's probably a little running time intensive. So I don't know. But cause yeah, but overall, yeah, my overall a fun problem I think. But and connected components just keeps on popping up in random places. I definitely maybe not one as hard as this one, but I've definitely ran into these kind of interviews